Hello and welcome to my math companion. In this video, we will be looking at how to solve a quadratic equation in a much faster way by recognizing that it's a perfect square. So this question tells us to solve x squared minus 14x plus 49 is equal to 0 by factorization. And when you look at this problem, you might say, well, it seems pretty simple for me to solve it by normal factorization. Why do I have to use a different method to solve this? And you will see that recognizing that this quadratic equation is a perfect square can really help you in solving the question much faster. And this can be of great help when you're doing a time test in which you're short of time. So in this video, I will be exploring methods that you can use to solve this equation by recognizing that it's a perfect square. But some of the methods will only be applicable when the coefficient of x squared is a 1. It's a positive 1. And technically, these methods are a shortened form of the more algebraic approach that you should take towards solving a question by recognizing that it's a perfect square. But I will be covering the more algebraic approach in another video where the coefficient of x squared is not a 1. So let's begin. If you have x plus some constant d the whole squared, and you would expand this this binomial, you would get x squared plus 2dx plus d squared. And you'll see that here the coefficient of x squared is 1, and this constant term that was there in the binomial is now being squared here as the last term of this binomial expansion. And if you want to represent our equation as a perfect square, it means that d square must be equal to 49, and that means that 49 must be a perfect square. And we see that 49 is a perfect square. It is positive or negative 7 whole square. And when you write 49 as a perfect square of some number, do not forget this positive or negative sign, since it will be extremely helpful to us in the next step. So the next step is to see, and this is the important step which can only be applicable if the coefficient of x squared is a 1. And in this step, we see where if b and b is the coefficient of x, we must see whether b is 2 times the square root of c. In other words, in a more algebraic form, b is equal to 2 root c. And this root c is just this number that we got here. So in our case, root c is positive or negative 7. And we see that b is equal to negative 14, which is equal to 2 times negative 7. Negative 7, not positive 7, it's 2 times negative 7. And that's exactly why writing positive or negative 7 whole square to be equal to 49 is extremely important. Because if you just write positive 7 whole square, you might think that, well, b negative 14 is not 2 times 7, so I cannot represent this entire this entire quadratic as the perfect square of a binomial. But that would be wrong, since negative 7 squared is also equal to 49. So we conclude that b is equal to 2 times the square root of c, and therefore we can factor out our equation to be x squared minus 14x plus 49 is equal to x plus the square root of c the whole square. And this is just an application of this binomial, since if we have some x plus d whole square, it's x squared plus 2dx plus d square, and here 49 is our c, so the square root of c is root c, and therefore we can write the entire quadratic as x plus the square root of c whole square. And this c is 49, so that is x plus square root of 49 the whole square. And here you must be careful of which value of square root of 49 you take, because you must take the value which you used to calculate b in terms of c. So here we used b is equal to 2 times negative 7 and not positive 7, which means here as well we must use negative 7 and not positive 7. So we'll say x plus negative 7 the whole square, and this can be simplified to x minus 7 the whole square. And now we have our simplified equation, which is x minus 7 whole square is equal to 0. Again, if you were to solve this entire quadratic equation just by normal factorization, you would also get x minus 7 whole square is equal to 0. The end result is not different. It's just that for some, the approach might be easier by recognizing that the quadratic is a perfect square. And x minus 7 whole square is x minus 7 times x minus 7, which means that either one of these two binomials must be 0, since if the product of two numbers is equal to 0, at least one of those numbers must be 0. And we see that both the numbers are the same, so we can just equate x minus 7 to be equal to 0. And if we just add 7 to both sides of the equation, we'll get x is equal to 7. And that is our answer.